April 2026. 4 astronauts. A spacecraft that had traveled 252,156 miles from Earth, farther than any human being in history. And then, when they went behind the far side of the moon, where radio contact with Earth cuts out completely for 40 minutes, they saw something with their own eyes that NASA's 31 onboard high-tech cameras couldn't capture. This isn't a conspiracy theory. This isn't some leaked UFO footage. This is NASA's official Artemis II mission. And what the crew witnessed is something NASA's own scientists are calling, in their own words, exciting. So here's the question. What exactly was on the dark side of the moon that cameras couldn't record, but the human eye could? If you're into space, science, and real NASA missions, hit subscribe now because we bring you verified, real stories like this regularly. No fake clickbait, no made-up claims. Just what NASA has actually confirmed. Let's rewind a bit. Artemis II launched from Kennedy Space Center, Florida on April 1st, 2026. This mission was historic because it was the first crewed mission to travel toward the moon since Apollo 17 in 1972, a gap of 54 years. The crew consisted of 4 astronauts: Jeremy Hansen, Canadian Space Agency astronaut and the first Canadian to travel this deep into space. They flew aboard the Orion spacecraft, call sign Integrity. It was a 10-day mission, a loop around the moon and back to Earth. And the most dramatic moment of the entire trip came on April 6, 2026, when Orion carried out a 7-hour flyby of the moon's far side, what most people casually call the dark side of the moon. Let's clear something up right away. Dark side of the moon is actually a bit misleading. That side isn't dark, because sunlight never reaches it. It gets just as much sunlight as the near side. It's called dark because it's permanently hidden from Earth's view. The moon is tidally locked to Earth, meaning the same side always faces us. So that far side feels mysterious and unknown to us, which is where the dark side nickname comes from. But in reality, it's just as bright as the side we see every night. When Orion went behind the far side, communication with Earth cut out completely for 40 minutes. During that window, NASA's mission control was simply waiting, because the moon itself became a physical barrier blocking the radio signal. And it was exactly during this blackout window, when there was no connection to the outside world, that the astronauts began a very specific scientific task, hunting for impact flashes on the lunar surface. So what exactly is an impact flash? In simple terms, when a small meteoroid, a tiny fast-moving space rock, slams into the moon's surface, it's traveling at such extreme speed that it vaporizes on impact, creating a brief flash of light. This flash lasts only a fraction of a second, fast enough that if you blink, you'll miss it. Because the moon has no atmosphere to burn these objects up before they hit the ground, these impacts are actually fairly common, but they're incredibly hard to catch, precisely because they're so fast and so brief. The astronauts were given this task because NASA's lunar scientists wanted to test something specific. Could trained human observers, watching from a spacecraft, spot these flashes in real time, when automated cameras often miss such fast events entirely? And what happened next surprised everyone. The astronauts didn't just see one flash. They reported seeing several impact flashes, with their bare, unaided eyes, no camera, no instrument, nothing but human vision. And when NASA scientists later reviewed the onboard camera footage, they found that the cameras had failed to fully capture those same flashes. So the question becomes, if we have some of the most advanced technology on Earth, with 31 cameras mounted all over the spacecraft, how did the human eye outperform the camera? The answer to that, and the real scientific significance of this entire discovery, is what we're breaking down in the next section. But trust me, what NASA's Kelsey Young said about this is going to make you look at this whole mission differently. Let's move on to Section 2. Quick recap. Artemis II's astronauts were behind the moon's far side, cut off from Earth, and they saw flashes with their own eyes that the cameras couldn't record. Now let's dig into the real scientific detail behind this whole mystery. NASA's Artemis II lunar science lead, Kelsey Young, explained this to Space.com in her own words. It's extremely difficult to capture impact flashes with a camera, which is one of the benefits of sending trained crew to observe the moon. In other words, cameras genuinely struggle to catch impact flashes, and that's exactly why sending trained astronauts into space to observe the moon directly has real scientific value. She also confirmed these observations were made with the unaided eye. Early data indicates that the impact flashes were observed on the far side of the moon. So this is confirmed. These were pure naked eye observations, no telescope, no special sensor involved, and the early data specifically points to these flashes happening on the far side. That hidden half of the moon we never get to see from Earth. So here's the real question. If Orion had a full 31 cameras on board, how did they miss these flashes? The reason is simple, but genuinely interesting. Impact flashes are such short-duration events that catching one on camera is almost a matter of luck. The camera needs to be pointed at the exact right spot, at the exact right moment, with the right exposure settings all at once. Cameras have a limited field of view, and they can't continuously monitor the entire lunar surface at once. The human eye, on the other hand, covers a much wider field of view, and the human brain is exceptionally fast at detecting sudden movement and changes in light. This is actually an evolutionary advantage that lets us notice things even in our peripheral vision. That's why trained astronauts, when specifically briefed to watch for something, become the best available sensor for this particular task. Better than the machines, at least for this specific job. This mattered so much to NASA that astronauts were given special training beforehand. How to watch the lunar surface differently, what patterns to look for, and how to document their observations in real time. Here's another cool detail most people don't know. While the astronauts were watching for these flashes in space, at that exact same time, citizen scientists back on Earth, regular people just like us, were also pointing their telescopes at the moon, hunting for the same impact flashes. This was all part of a project called Impact Flash, run under NASA's GEODAYS program, short for Geophysical Exploration of the Dynamics and Evolution of the Solar System. It's a unit within NASA's Solar System Exploration Research Virtual Institute. The project's own website explains, and these flashes are vital to scientists who study the moon. By tracking when and where they happen, scientists can learn how often impacts of different sizes occur, what kinds of craters they create, and how the shock waves travel through the moon's interior. So this wasn't just a cool moment. It was a fully coordinated scientific effort where astronauts in space and thousands of citizen scientists on Earth were tracking the exact same phenomenon simultaneously, so the data could be cross-compared in the future. An expert in this exact field, Benjamin Fernando from Johns Hopkins University's Department of Earth and Planetary Sciences, told Space.com that the astronauts' observation window actually extended beyond the far side, into the darkened portion of the near side too. In a research paper he co-authored, posted earlier this year on the preprint server EarthArXiv, Fernando and his colleagues reported that when impact flash, observations are gathered simultaneously from Earth and from a lunar flyby or orbit. Scientists get far more detailed information about the timing, location, and dynamics of these flashes than either method alone could provide. In simple terms, when Earth-based telescopes and astronauts in space both watch the same event, we get a much fuller, more complete picture of how meteoroids are hitting the moon, not just a single angle. Now you might be thinking, okay, but why does watching a few tiny flashes matter so much? Here's the answer. This isn't just a cool cosmic moment. It's directly tied to NASA's next massive project, building a permanent human base near the moon's south pole. And for that, NASA needs to know exactly how often, how big, and how intense these impacts are. Because if humans are going to live there long term, they need to be protected from them. And alongside this discovery, Artemis II achieved something else that's now written into history. 2 brand new craters, personally identified and named by the astronauts themselves. That story is just as emotional as it is scientific. Let's move to section 3, where we'll talk about these new craters and exactly how this discovery feeds into NASA's future moon base plans. Beyond the impact flashes, Artemis II uncovered something else, arguably the most emotional part of the entire mission. 2 brand new craters that had never been officially documented before. As the astronauts passed near the terminator line, the boundary between lunar day and night, near the far side, they spotted 2 small craters that were clearly captured in their camera lenses. The astronauts themselves suggested names for these craters. One was named Integrity, after their Orion spacecraft's own call sign, and the other was named Carol, in honor of Commander Reed Wiseman's late wife, who passed away from cancer in 2020. This moment became one of the most shared, most emotional parts of the entire mission. An astronaut, on humanity's farthest journey from Earth ever recorded, chose to name a crater on the moon after his late wife. This isn't just science, it's a genuinely human story too. During the same flyby, the astronauts witnessed another rare event, an in-space solar eclipse when the moon passed directly between the Orion spacecraft and the sun. During this moment, astronaut Victor Glover said something that became the defining quote of the whole mission. He said, "We just went sci-fi. It just looks unreal." He described the sun completely disappearing behind the moon, while its corona, the glowing ring around the sun, was still visible, forming a halo around the entire moon. Earth was bright enough to be clearly visible in the background, hanging right in front of them. Scenes like this are so rare that no human had ever witnessed one with their own eyes before, because it's only possible when a spacecraft is positioned at the exact right angle for everything to line up perfectly. Now here's the real point. All this data isn't being collected just for cool photos. NASA has a big, long-term plan called Artemis Base Camp, a permanent or semi-permanent human outpost planned near the moon's south pole. And to design this outpost, NASA needs to account for every single risk astronauts could face while living there. A 2025 study led by MIT's Daniel Yahalomi states, to design for longevity, one must account for the myriad environmental hazards that a long-duration outpost will face, among them radiation extremum, thermal cycling, regolith dynamics, seismic shaking, dust, and, of particular importance to this work, impacts. In other words, radiation, extreme temperature swings, dust, moonquakes, and meteoroid impacts are all factors NASA needs to plan for if humans are going to live there safely, long-term. The same study also found that the South Pole location naturally offers a lower impact risk compared to equatorial sites, making it a strong candidate for sustained human presence. It also confirmed that current shielding technology can reduce micrometeoroid hazards by nearly 5 orders of magnitude, bringing the risk down to a manageable level for current habitat designs. So here's where everything connects. Those impact flashes the astronauts saw weren't just a wow moment. They're real-world data that will help scientists understand exactly how frequently meteoroids hit the moon, how big they typically are, and how much of a danger they could pose to future human residents. Every flash, every new crater, every observation is a piece of a much larger puzzle that will determine how, where, and how safely humans can eventually live on the moon. So far, we've covered what the astronauts saw, why the cameras failed, and why all this data matters for future moon missions. But there's one last fascinating angle left, one that might make this whole story even more interesting. Have you ever wondered, if there was sound on the moon, what would it actually sound like? Space doesn't carry sound at all. So what are these mysterious sounds from the dark side of the moon that go viral online all the time? In Section 4, we'll dig into that too and wrap up the whole story, including what's next for NASA and what this discovery really means for humanity going forward. Let's take an interesting detour that actually deepens this whole story. You've probably heard claims like NASA recorded eerie sounds from the dark side of the moon. Where does that actually come from? And how does it connect to this new Artemis II discovery? The truth is, in the traditional sense, sound simply cannot travel through space because sound needs a medium, like air or water, to move through. Both space and the moon are near vacuum environments. The moon's atmosphere is so thin that sound waves practically can't propagate across its surface. So what exactly are these sounds from the dark side of the moon that keep circulating online? They actually come from a process called sonification. Sonification means converting data into sound. When spacecraft instruments record electromagnetic vibrations or particle interactions, signals our ears could never naturally hear, scientists convert those signals into audible sound waves. This helps researchers and the public detect patterns and anomalies more easily than staring at raw data alone. According to a recent report from The Guardian, NASA and scientists are currently working on making these sonifications even more advanced, so that people, especially those who are visually impaired, can listen to space data, not just look at it. This whole story actually goes back decades. In 1969, the Apollo 10 astronauts, Thomas Stafford, John Young, and Eugene Cernan, heard a strange whistling sound while they were behind the moon's far side, which they described as outer space-type music. This recording stayed classified in NASA's archives until 2008, when it was finally released to the public. Scientists later explained this wasn't some mysterious moon music at all. It was actually radio interference caused by overlapping signal frequencies between the lunar module and command module's communication systems. A completely natural, explainable phenomenon, but strange enough sounding that people still call it space music to this day. So notice the pattern here. It's the same one we saw with Artemis II. Humans experience something that feels unexpected. Science explains it, and it becomes a fascinating chapter in the history of space exploration anyway. Let's pull the whole story together. Artemis II in April 2026 carried humans back toward the moon for the first time in 54 years. 4 astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, set a new record for humanity, traveling 252,756 miles from Earth. Behind the moon's far side, where radio contact cuts out for 40 minutes, they saw several meteoroid impacting, flashes with their bare eyes, something NASA's 31 advanced onboard cameras couldn't fully capture. This discovery matters because that data will directly feed into NASA's next major project, Artemis Base Camp, planned near the moon's south pole, helping scientists understand exactly how much danger meteoroid impacts pose to future human residents. During the same mission, 2 new craters, Integrity and Carroll, were discovered and named, one in honor of an astronaut's late wife, And the crew also witnessed a rare in-space solar eclipse that, in their own words, looked sci-fi. Now, here's a question for you. If you were the astronaut on that far-side flyby, seeing something no human had ever seen before, what do you think you'd notice first? Drop your answer in the comments below. If you enjoyed this video and want more real verified NASA and space discoveries like this, please hit that like button, because that's exactly how YouTube's algorithm decides how far this content should reach. Don't forget to subscribe and hit the bell icon so you get notified the moment we cover the next big space discovery. The Artemis program is just getting started. Artemis II is set to actually land astronauts on the moon's surface in 2027 for the first time since 1972. And if a single farside flyby on Artemis II revealed this much, imagine what we'll discover once humans are actually walking there again. We'll end the video here, but this story is just getting started. See you in the next video, where we'll cover Artemis II's plans and exactly how that South Pole Base Camp is going to get built.